Hi everyone. Today we're going to be solving trig equations. So before we get started, I want you to just practice solving regular equations and think about the unit circle a little bit. So go ahead and try this warm up, pause the video, and then you can unpause it to see the solutions. All right, here are some answers. A couple key points about this. On this one, we can divide by 4 and square root. Don't forget the plus or minus. When you square root a fraction, you can square root the top and the bottom separately, and so you get plus or minus square root 3 over 2, which should be familiar to you. This one, don't forget, you can't just add the x and divide by x, which people sometimes try to do. You'll miss a solution that way. So you have to factor it, and you get two solutions, x could equal 0 or 1. And then this one, when you have a quadratic that can't be, that's not like letter A, then you have to make it equal 0 and factor, and so we get two answers there as well. Then for number 2, this was a little stretch, so hopefully you were able to think about your unit circle and think, where on my unit circle does the y value equal -1? So I like to draw little pictures to help me see the parts of the unit circle in my head. I just put them on my paper really small, then I can identify the values easier. So check those out, and hopefully you got all the same answers as me. Like I said, we're solving some trigonometric equations today. And so we are going to keep it simple today and then deal with some more complex ones tomorrow. All right, so on your notes, you have the same page, but you're just going to fill in the blanks. So fill in the word. First thing we do is isolate the trig function. We get the trig part by itself, kind of like when we solved logs and we got the log by itself or the exponent by itself. Here we'll get the trig function by itself. Then we'll find all the solutions on the given interval between 0 and 2 pi. Basically, we're going to be using the unit circle. So I'll add a little note here. To get exact values. And then if you don't get an interval directions, then you will be finding for all reals, which we'll go over how to do that. So hopefully you filled that in. Let's do our first example. So we're going to do it both, once in purple, once in blue, for the two different types of questions that you could be asked. The main thing, step 1, is to isolate the trig function. So we want to get sine of x by itself. We'll divide by that 2 in front. Then we think, where on our unit circle does sine of x equal 1/2? Well, 1/2 is small, so that is close to the x-axis because sine is y. And there are two values on the unit circle where sine equals 1/2. That's going to be x equals pi over 6 and x equals 5 pi over 6. And so that is what I just did there. I meant to make it purple, but it's too late. So we do that, and then we'll do for all reals as well. You know that the unit circle is just one set, and it could go forever and ever and ever. It's something that is periodic, which means that it just goes forever and ever and ever. So that means not only is x equal to pi over 6, but if I do for all reals, then I have to consider x could equal pi over 6 plus any other value that's 2 pi and away from it, from pi over 6. And so that is x equals pi over 6 plus 2 pi n. It'll keep repeating itself every time it goes around the circle. Same thing for 5 pi over 6. So I could start here and go one full revolution around the circle, and I'd get another place with a solution. And I could do that an infinite amount of times. And so we use an equation. For all reals, we add 2 pi n to our solutions. And here, for the other one, we're just looking at unit circle. All right, so we'll do a few more practice. So I'll try to keep my colors right. So between 0 and 2 pi, let's isolate the trig function. When does tan of x equal 1? Well, we already did this on the warm-up at pi over 4 and at 5 pi over 4. And so those are my two answers from 0 to 2 pi. And for all reals, we want to just think about it. Here's pi over 4. So if I do 2 pi n, I would actually be able to do something smaller. With tan, I could actually just go pi n. So if it's on the diagonal, then you can add pi n. So if I add 1 pi, I'll get to the next one, and then I add another pi, and I get back to it, pi, pi. And so when it's on the diagonal, I don't like how that pi looks. Let's fix it. So when the solutions are on a diagonal, you can add pi in. So you got to think about it. We don't want you to have too many equations for your answers. We want you to make it as simple as possible. And so this is the correct answer here with pi in. You could technically add 2 pi into each one, but that's too much. So don't do that. Now there's some other things. What if it's squared? So remember to square root, there should be a plus or minus. You have to factor, set equal to 0, find the GCF, and then factor as you would. Make sure you get this page filled in on your notes with the missing values or words. And we'll see some examples here. So we follow the same steps. Find or isolate the trig value. So that's going to be cosine squared of x equals 3/4. And then we'll square root both sides. So whenever you square, don't forget plus or minus, square root 3/2. Square at the top and the bottom, both. And so in this case, I'm going to draw my circle. Cosine is square root 3/2 here and here. Those are the pluses. And then minus square root 3/2 here and here. And so it says for all reals, not on my unit circle. So what I'm going to do is try to make this as simple as possible. I'm going to pick the first one, pi over 6, and it's on a diagonal with 5 pi over 6. So I can get to it with pi n, and I'll do it again with the other one I didn't get to yet. I meant to say 7 pi over 6, by the way. Yeah, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So 5 pi over 6 and 11 pi over 6 are on the same diagonal. So I'll start with the smaller one and then add pi in, and that would get to it. And it would just keep going around and around and around. All right. So those are our two answers. It's kind of jumbled, so I'm just going to highlight these. Okay. Try the next one. Oh, this one looks tricky. So for this one, I cannot divide by tan of x. I know you want to. Many of you probably think, let's just get rid of the tan of x. But you'll be missing a whole entire solution that way. The tan of x is important. So I want to do square root 2 tan x cosine x minus tan x equals 0. We have to factor out the tan of x. And then we will solve separately. So if we didn't do that, then we would have a problem missing one whole set of solutions when tan equals 0. And so let's finish this one on the right first and rationalize so it matches how our unit circle is. And then we can solve each of these. So when is tan equal to 0? Okay, well, tan is y over x. So if it equals 0, then the y has to be 0 and the x has to be 1 or negative 1. So that's going to be here and there, which is at 0 and pi. Then over here, x equals square root 2/2 for cosine. And it wasn't plus or minus or anything, so that's here and there. And so I'm going to write pi over 4 and 5 pi over 4. So if I put them all on one circle to try to get all my solutions, then what I'm going to do from that is just put them all together. And so I will do that, and then we will see what it looks like. Let's just do a blue one here in the middle. We have pi, this, that, and that. So unfortunately, they are just going to have to be 3 separate answers. So we're going to have x equals 0 plus pi n. That will get me this and this. And then I'll have to do x equals pi over 4 plus 2 pi n. So I got to come all the way back around the whole circle, and 7 pi over 4 plus 2 pi n, which means I wrote the wrong thing here. Okay. Ooh, those are so fun. I love solving trig equations. They're really good fun. And these are all three our final solutions. And it says for all reals. Oh, my goodness, Miss Pendleton, what are you doing? This one did not say for all reals. This one said from 0 to 2 pi. And so what I'm going to do is erase all of this. If it had said for all reals, I would have done that. And I'm just going to box in these answers and these answers. So x really equals 0, pi over 4, pi, and 7 pi over 4 if I put them in order. Oops, that's better. Okay. Next. Only three more, sorry. Okay. So on this one, we will factor. This says from 0 to 2 pi, so pay attention to that in the beginning. So we're going to take out a sign, and we'll have sine of x minus 2. That means sine of x equals 0, and sine of x equals, well, minus 2 equals 0. And so we'll solve this one. Now, my unit circle, it really only goes, well, let's do this one first. Sine is 0 at there and there, so at 0 and pi. But the highest the y values go is 1. And so this one actually doesn't have a solution. And so the answer is just 0 and pi. The highest y value that it goes is 1, so sine of x cannot equal 2. Let's do this next one. This one needs to equal 0. And this one looks a lot like that one on the warm-up. So what I'm going to do is I'm going to make it a little simpler on us. I'm going to say, let's let a equal sine of x, and rewrite this as 2a squared plus a minus 1. Because that looks like something I can solve. I actually did it in the warm-up. 2a plus 1, a minus 1. Oops, those are not right yet. 2a minus 1, a plus 1. So that way I get 2a minus a is positive a. And so that gets me a equals 1/2 and a equals negative 1. But remember, I'm not solving for a, I'm solving for x. And so now I'll replace this back. A is sine of x, so I'll replace it with sine of x and have sine of x equals 1/2. Sine of x equals negative 1. So where on my unit circle does sine of x equal 1/2? Well, right there and right there. So pi over 6 and 5 pi over 6. Where does it equal negative 1? Down there at 3 pi over 2. All right, one more. These are so fun, though. I hope you guys are having as much fun as me. Oh, but this one is a little tricky. I don't know what to do with sine squared and cosine squared, because I could say let a equal sine of x, but then I would have to say b equals cosine of x. And so there's really not a lot I can do with that right now. But if you guys remember when we did our unit on the parametric equations, sine squared is equal to 1 minus cosine squared of x. And so we can do 1 minus cosine squared of x plus cosine of x equals 1. By the way, the reason I knew that is because remember this formula. And so if I want to solve for sine squared, I can just move the cosine to the other side, and that's what I get. And so now I can just make everything, I like to have the squared stuff be positive. And so I'm just going to move everything to the right side. And the ones cancel. Now this is something manageable. So I can take out a cosine and I can solve each of these. So where does cosine equal 0 and 1? Well, here's where it equals 0. And when x is 0, it's here and here. And it equals 1 there. And so if I look at all those, I only have 1 on the diagonal. And so I'll have to do x equals 0 plus 2 pi n. And then pi over 2 plus pi n. So this one I need to go all the way around, but this one I can go halfway to get to the next one. And that covers all 3 solutions. So we have all reals when we add in the ends. You can simplify our answers a little bit. All right. Hope you guys had as much fun as me doing all that math. Now check Canvas for what to do next. Thanks for having a great time.